W. Moore, and welcome to Lesson 6 of Learning Synthesis with Pure Data. In the previous two lessons, we've been going modular by making a MIDI input module and then a carrier oscillator module. And so far we have something that will allow us to play notes on a MIDI controller and have those notes come in and it plays them. But now we want to be able to shape the note's amplitude. We want to be able to start and stop notes when we press and release the key. And we also want a little bit of shaping to its amplitude so it's a little more expressive. We're going to do this by creating an ADSR envelope. And ADSR stands for Attack, Decay, Sustain, Release. And it's probably the most common type of envelope that gets used in synthesis. And so we should know how to make one. So that's what our mission today is. And Crafty's going to make sure I keep my Pure Data patching nice and clean. So without further ado, let's get to patching. Okay, well, so now we're going to get to patching in a second. First of all, I just wanted to once again point out my website. It's changed. It's looking, I think, a lot better now. I'm using WordPress and I put in some new graphics and stuff. And this is a learning page right here, as you see, menu bar on top, lwmmusic.com. And scroll down, here's lesson 5, the previous one. And basically, down below the lesson, there's a link here to the download of the materials from that lesson. I basically zip up the materials at the end of each lesson and upload them there when I put up the videos. So anyway, the next one will appear here right above this. So anyway, let us move on to the work at hand. And as you'll see right now, it's looking a little different. I didn't want to make all these adjustments on video because they were mostly, what would you say, beautification. And I don't want to take your time doing that and make the videos a lot longer. So let me just show you what I did. First of all, here's the folder where I'm keeping this stuff for this lesson. And I have all the subpatches here. The file I have open is called modules. Just like we ended last time, it has all the modules that we're using. I'm going to start from the bottom. This is a new module. This one is an audio output module. Signal basically goes out into here where it gets sent to the DAC, but also you have record functions here. It has a volume control for the sound coming in and to be recorded, and then just a monitor control that doesn't affect the recording if you're recording, and this is just your level control to make things quieter if it's too loud. This is the module we'll be going over today, the ADSR envelope. I made it graphically to start because it's basically the same procedures we've been using for the other ones. Nothing really new. So I figured I'll save time in this video by doing that ahead of time, and I'll show it to you in a minute. But all the patching, like to make it work, is what I'm going to do now with you so you can learn about it. This is the oscillator module that we made last time, and this is the MIDI input module we made in lesson 4, I believe. This is lesson 5. This is going to be lesson 6 now. And so the only thing that's different here, let me open it, is I changed its look by putting a black canvas in behind the canvas that we had and put the label on that, and then made this smaller so that it has a large border at the top and then a border around the side and bottom, and the large border at the top allows the label of the underlying canvas to show through here. And then this allows me to cover up the underline that PD puts in automatically. And then we still have our channel and all the controls we had before, but these are now horizontal sliders. And I actually hooked them up because I did not hook them up originally. But the rest of the patching is the same. That didn't change. Okay, and so I'm going to go over here to the oscillator module. This, graphically, I did the same things. And then what I did is I put the selector that we made and all the oscillators on the inside of a subpatch here. So this patch is just really copied, cut and pasted and placed on the inside here, and I just put inlets at the top and an outlet at the bottom so it can feed out. So that way the phase, pulse width modulation go in, as well as the wave selection, and then the frequency goes in here, and it's all organized in there. The reason why I did this is we're going to be eventually making these modules polyphonic, meaning allowing you to play more than one note at a time. Literally in PD, you need to make multiple oscillators for that. So I thought it'd be easier just to duplicate this, feed the information to it appropriately, and then, we'll see how that works when the time comes. But I just wanted to do it ahead of time. But the table writing for the display is the same, and we're cool there. So anyway, I'll close that, and this is what we're going to work on today. Basically, what we have here are 4 horizontal sliders: attack, decay, sustain, release, so that you have settings for them. And at the top I have a number box, officially a number 2 box. And what this is this is going to allow me to set an overall duration time that these things will scale. Basically, it allows you to set kind of a global range of how long things will be, and in a minute as we patch you'll see exactly what it's for. But it allows you to kind of like make some fine-tune adjustments. Now typically ADSR envelopes have vertical sliders on them, but I made them horizontal so that the display could be on the inside, because I was having trouble fitting them along with the vertical sliders. The numbers would run into each other at the top, and plus here when you put the numbers on the inside it takes up less space, and it's just a more efficient design really. So anyway, this is just MIDI in with the pack, the unpack, like we used in the previous module. This is where we'll get our velocity from, because that's the information that this module needs. And then we have the inlet here for the audio signal to come in and then go out. But this amplifier here is where the stuff we're going to make now shapes the sound. So now I'm going to zoom in. Oh, there we go. And let's move our zoom thing out of the way. Put it down here. Magnifier menu. Or actually just minimize it. There we go. So now I'm going to make this into a subpatch. The reason being is, once again, when we go polyphonic with these modules, it'll just be a lot easier. So I'll just call it PD ADSR tilde, and that's it. Okay, so in here is where I'm going to set up all the functions. It's mostly math, and so I'll take you through that. But I'm going to put inlets at the top because there's certain things we need to do this. First of all, we'll have an inlet for the velocity. Then I'm going to hit Control 3 right away to give me a number box below it, so that way we could see the velocity that comes in, like when we're testing it out. Then we need an inlet for attack. Oh, actually duration there. Duration. Control 3 for that. Then we need an inlet for attack, decay, sustain, release. Oh, put it right there. Okay, inlet, attack. Control 3. Alright, now move this up here. Now I should be free to put, excuse me, just moving around here. I should be free to put, come on, spread out. There you go. I should be free to put the next 2 or 3 actually I need. Sustain. I'm just duplicating to make it quicker. In case you haven't done this before, oh, I skipped decay. The word that you type after inlet is really just a comment. So it's just information for you so you know what inlet is bringing in what. It doesn't do anything as far as PD is concerned. But I like to have them labeled, that way I know which inlet's doing what. And then we need a little more space here for the release. Actually, I'm going to make these a little more space efficient in a second here, because I think I'll be able to fit all this on screen. Move this over here to the left. Move this one right here. Move this one right here. Move the rest of these over here. Little by little, we'll get it all there. Okay. Now I'm just going to make sure the window fits in screen. Put that down. Alright, there we go. Now, it may shift off screen a little bit here and there as I move my mouse. It's kind of annoying, but anyway. So, first thing, we'll have velocity coming in here. And velocity will basically be whatever rate at which you hit the key, which kind of is MIDI's way of translating strength, or how quick your attack should be. And you can have that affect attack time if you want, although I don't think I'll do that. I may add that function later. But what we're going to have it do is control how loud our envelope overall gets. But we also need it for its 0 message, which means to release what's happening. Because what the whole envelope does is the attack is basically right here. This is how quickly the sound goes from 0 or silent up to how loud it's going to be in amplitude. And then decay is how quickly it slopes down to what we call a sustain level. And then the sustain is going to be a function that will scale the velocity, or scale the amplitude actually, we'll translate it by then. And what it does is it says, okay, our attack's up here, over a certain amount of decay, it decays down, and then what level does it stay at to sustain while you're holding the key down? And then the release is how quickly it goes to 0 when the note gets released. But this only happens once you lift up the key. And so that's how this thing's going to work. Now, our velocity coming in, we first need a select 0 object. This will tell us when a 0 comes in, and it'll allow us to send this 0 message, as well as other things we may set up to different things. Now this one here, we're going to set up with a couple of things. I'm going to make, and it added it to this. Didn't want that. I'm going to make a trigger bang bang float. Now remember, triggers say that when something comes into its inlet, it triggers a number of things to happen. What's going to come in is a float. It's a number. It'll be the velocity number when it's not 0. Because basically, when velocity comes in here, if it's 0, it bangs this out. If it's not 0, it comes out the right outlet. So that's any of our numbers. It could be 1 through 127. Anything except 0. Trigger, bang, bang, float. And I'll show you why in just a moment. because basically we do want the number to come through as a float, but it's going to be stored right in here by putting it into a float box, which is just an F, an object with just an F. You could also type out the whole word float, but why? This takes up less space. And then a float box, when you have a right inlet, something going in the right inlet, it gets stored, and then when you send a bang to the left inlet, it comes out. Now we have this trigger set up to do two bangs. One of them is going to go into a delay object with a delay of 10 milliseconds. Now 10 milliseconds is a very short amount of time. Extremely short that you don't even notice it. But in PD, that's just enough time to make sure other signals get sent before this happens. Basically, this will bang out the number in the float box. Basically, it's saying our number here, our velocity number, is going to be sent after 10 milliseconds. Before it gets sent, though, this needs to do a couple things. I'm going to hook it up to a 1 message. Now, the thing is, I'm going to come back to this. I'm going to set up the other things so that this all will make sense. Now, our attack time. The way this is set up, and I minimized the other thing. Let me get it up here. Here's the display. Basically, we're going to have a duration time that's in milliseconds. I set this number box to have a range of 1,000 to 5,000 milliseconds, 1 to 5 seconds. And what's going to happen is, I might adjust that later after I try it out. But right now, your attack time is a percentage. It goes from 0.01 up to 1. So it's like 1 to 100%. It will get multiplied by this duration. What that means is that, let's say you set duration to 1,000 milliseconds or 1 second. When an attack time of 0.01 gets multiplied by it, it basically makes it 10 milliseconds, which is really fast. And so that would mean a short attack time. If you push it all the way up, it'll be 1,000 milliseconds or 1 second attack time, which is slow. So you can adjust your attack time accordingly, and it gives you a pretty good range to work with. I don't know why you'd want to have a 5-second attack time, but it depends, if you're doing some artsy music and stuff like I do. Sometimes you have some really, bizarre and strange settings because the music you're doing is much more experimental or expressive. It's not typically what you would use. But in any case, we'll see it working later. And then the decay and release work in the same way. They are percentages of this duration. And so they basically judge how quickly things happen. The attack time, how quickly the note comes in from 0 up to its amplitude, which is governed by the velocity, what its peak amplitude will be. And then the decay time will be how quickly it goes down to the sustain level. The sustain level, that will be a number that when you move the slider, it's also a percentage. It'll be a percentage of the velocity. Your velocity that comes through will be the peak. Like after the attack, that's your peak amplitude. And then the sustain level is a percentage of that. Let's say you set it to 0.80. That means 80%. So if your amplitude, let's say you hit a note at 127 velocity and your amplitude is a full blast 1, this will make it 0.8 is your sustain level. And your attack peak will be 1. So that's how sustain works. And then release is, once again, going back to milliseconds. It multiplies how quickly it goes from that sustain level to 0 again. Alright, so now what we're going to do next is our attack time like all these things, need to be multiplied by the percentages that come in. So let me set up that kind of a thing. We'll use a star asterisk here for multiplying these percentages. And then the way math functions work in PD, if your duration's hooked up to the left inlet, whatever comes through the right inlet doesn't actually get multiplied until this gets banged or a new number comes in through here. So we want to get around that by making a trigger bang float, just like we did in the MIDI module. This means that when this number comes in, it will automatically multiply. Okay, so what we get here will be the result, and it'll be the time in milliseconds that you set through duration and your attack settings. Let's just make sure we take up less space here. And I'm a little anal. Well, Crafty makes me anal, sitting over there watching me. Okay. Let's multiply. Let's duplicate it. Because each of these is just going to be a different percentage of your duration time. I'm skipping over sustain because remember that sustain is just going to be the percentage of your velocity or the amplitude level once the velocity is converted to amplitude. Okay, there we go. Now, sustain, like I said, is a percentage of the amplitude level, which gets calculated from your velocity. The velocity eventually comes out here, and it's going to get divided by 127, which converts it into a range of 0 to 1, like a percentage. And so that way, full velocity 127 equals 1. 0, of course, actually goes through the other outlet from select and does its own functions, but anything in between is whatever percentage of 127. It's a range of 0 to 1, basically. And so this, well, I could use these same structures here. Hold on. But basically this gets multiplied by this for what the sustain level will be. I patched that wrong. This goes into the left inlet of the multiplier. There we go. And you see all these bangs from the triggers go into the left inlet of the multiplier too. That left inlet can receive floats as well as bangs. The bangs means calculate and send a number out. And the floats mean, all right, calculate, here's the new number, calculate, and send the number out. But when you change these numbers, it doesn't calculate automatically because they're going in through the right inlet. And so you need to have this trigger bang float there to make sure it bangs and sends the number out. Otherwise, it just stores the number in the right inlet. Kind of like the float box over here works. Right inlets frequently store numbers in this type of setup. Same thing with the pack object that packs up these messages. Okay, so anyway, we have these all set up and good to go. They're providing their calculated numbers now. Now we need to make the system by which things happen. And eventually what's going to happen is we're going to send everything through a line tilde object. And that line tilde is going to go out the outlet into the amplifier. Basically what we're sending is changing amplitude numbers over time. We've converted our velocity into amplitude here, here's the sustain level, and now here's going to be the peak level. So let me just put a number box here. So we have our peak level coming out here, which is the level that the attack ramps up to. Alright, now remember, line receives numbers, and these numbers will be amplitude numbers, but they're numbers in pairs. The first number the amplitude, the second number the time in milliseconds, which is perfect for what we're doing here. So the attack time is a time in milliseconds. So it's going to be packed together in a message of two floats, where this line object will receive a message that says, here's the peak level, go to this and go there over this amount of time. Now, I need to put at the bottom of this something that we're going to put for now, spigot. And I'm going to put a 0 as the default, or the creation argument as it's called. I'm going to put it across for all these items. Hold on, I'll think about this one in a minute. Basically, another thing's got to be set up here. Notice how I still have an extra bang here. And it's going to this 1. Okay? Let me put this 1 and this 0 next to one another, because they're kind of part of the same purpose here. Okay. Basically, when a 0 comes through here, see, I set up a mechanism here. When a 0 comes through, this message gets sent. When it's not a 0, well, we're going to use the number, but also this 1 is going to be sent. These 0 and 1 messages are sent to these spigots to turn them on or off. Remember, a spigot is like a valve. And basically, when it receives a 1 through its right inlet, the valve is open and things flow through the spigot. When it receives a 0 in its right inlet, the valve gets closed and it doesn't let things go through its left inlet. Now I'm just going to create a little more space here because we already got cobwebby and Crafty's getting antsy about that. Here we go. There we are. Okay, and we'll hook these guys up as well. Now I didn't hook up the far right spigot there because I'm thinking that's going to have to receive the opposite. Or actually, no, it doesn't need a spigot at all. At all. Okay. Now, let's move this down. So, let's start from our first thing. A key gets hit at a certain velocity. Number comes here. The 1 gets hit. The spigot's open 10 milliseconds before this number gets sent out. That's what our delay 10 here is for. It sends this calculated velocity, which is now amplitude after it's divided by 127. It gets sent out. Hold on here. I put a number box here. Why don't I connect this up to the number box? There we go. Haven't come out of the same place. So, okay. Yeah, we need that here for the sustain level calculation. But also this number is going to be sent hold on. We need one more spigot. Or actually, we don't. We don't for this. Don't worry about it. Okay. This number of the velocity converted to amplitude gets sent, first item in the pack. Now we need another trigger bang float. And the second item in the pack is going to be the attack time. So basically, the line receives the number it needs to go to, and the amount of time in milliseconds it needs to go there. And that goes out the outlet. That'll go to the amplifier on the outside. Alright, so now we're starting a whole chain of events here. And I need to add to this trigger bang float, because in addition to it, it needs to bang the next chain of events to happen. When you add things to the right, you're okay. This bang is still a bang. It was the first item. Second one is float. Oh, what am I doing? This bang hooks up to the left side of pack, because pack is just like the math objects. When something gets sent into anything but the left inlet, it just stores it. So here's the float. This is the time in milliseconds. It gets stored here, but since this bangs at the same time, it sends it out. That way, the message gets sent when it comes out of here. Okay. Well, actually, we don't want that. I'm sorry. Thinking on the fly. So I'm going to disconnect this. Otherwise, you'll hear notes turn on when you change your attack time. Or probably you wouldn't, because we have the spigot there, but, well, anyway, just to be safe, this float should just get stored here as your attack time. It should only come out when the amplitude is sent into this inlet and it bangs it through at the same time. Okay, good. So anyway, this bang then starts the next chain of events. And what I'm going to do is put delay, and its creation argument is going to be, I'll say 10, but that 10 will change. Because what I want it to do is basically a bang's coming out here, and when you bang a delay object, it sends the bang out its left outlet, or its only outlet, after it delays this amount of time. And the amount of time I want it to delay is the attack time. So this float also goes here. To be cleaner about it, I could just add another F to this chain. It'll look cooler. So the same float also gets sent out this outlet right there to delay. Okay? And then this bang bangs after that delay. What it's going to bang is the next items. Now the next item here is sustain level. And to be honest with you, the sustain level does not need a spigot. In fact, it should not have one. Because that's the next thing we're going to go to. We're going to make another pack FF. And the first item in this packed message is the amplitude once again, which is our sustain level now. And the amount of time that it goes to that is over the time in milliseconds coming out of here, which does not need to be triggered out on this occasion, because this is just the next in the chain of events, and the chain kind of stops here while the note's sustained. This gets triggered when a 0 comes in through here. So it does not continue the same chain of events. So anyway, it goes to the sustain level over this amount of time. When this is banged, it will come out actually I need to do it like this. If I have that hook up to the left inlet, whenever the sustain level's entered, I'm going to rehook this up, it'll come out, and I don't want that. I want it to go into a float first. So we're going to make a float box. And they're designed, just like before, for storing numbers. It'll store the sustain level through the right inlet here, but it's only when this delay goes off that that gets banged into pack, which triggers the whole message to be sent. Okay, and then this pack then gets hooked up to line tilde again. Alright, so that's our first two sequences. Basically, the attack time rises to the peak level that came in here over the attack time, and then after the attack time's over, which means it's at that peak level by that point, it triggers the next sequence to happen, which goes to the sustain level stored here, and this delay bang triggers that to come through with the time in milliseconds of the delay, and it sends that information to line. So now we're at the sustain level, and it sustains the sustain level until you release the key, and that's when a zero velocity comes in. It shuts off these spigots, because let's say you release the key while you're still sloping up or sloping down here. It shuts these off so that this delay doesn't bang this through, and it just makes sure these remain closed so that they don't interfere with line by sending anything through. And what it does is it's going to trigger this release time to happen. And so, in addition to these places, we're going to have this serve as, when the zero gets hit, it will also be sent with the release time to line. And that should take care of everything that I can foresee thus far. What we're going to have to do is test this out, because I do not claim to be perfect, and there could be a mistake that I made. I made these a few times before, but, well, several times before, but you don't know. So anyway, I also need to make sure I hook up things on the outside. So I'm going to close this window. And here we are with our subpatch. Now, the first thing that comes in is velocity. It's the second item in our packed message. Nope, it's the first leftmost inlet. I missed it. There we go. The second item is attack time, which is set here. Nope, that's the third item. The second item is duration, which is set here. Then we have decay. Sustain. And release. Now this, let's leave here like this, and its outlet gets hooked up here. It controls the amplifier. Now what I need to do first is send values in. Let's do 1000 or 1 second. Let's put our attack like that, fairly quick. The decay time, I'll give it like about that much. Sustain level, let's have it here so we can actually hear that it is less than the velocity peak, or peak velocity. And then the release time. We'll give it that much for now. All right. Now I'm going to save. I'm going to close this. I believe everything is hooked up. So if I go up here to the media menu, I'm going to first double check my audio settings, make sure I have the right thing. It is not the right thing. We want to come out the Afterglow headsets that I'm using. I set the input to, well, doesn't matter. Okay, media, let's go to MIDI. It's not on the right thing. SL Mark II. Okay. Okay, I hear some sputtering. Let me check in here. Here we have the first value should be the note. Phase 0, pulse width, that's fine. Let's open this up, see if our frequency value is something usable. This is the wave select. I'm getting zeros. You see the frequency 0. Alright, well, we gotta check on that. That would be, hold on. These all have M2Fs on the inside, right? Yeah. So this isn't frequency yet. I should even correct this, because really this is note. But I'm seeing 0 there. See, it's 0. It's not a note number. Okay. Let's see what's going on up here. Coming out the left outlet here. And here's the packed message. 4 things. First item, that is note at the top, right? Yep, and it's saying 50. Velocity, well, 0 now. I let go of the key. Those are fine. But those are note values. They shouldn't be coming through as zeros. I've got to see what's going on here. Well, one other thing, make sure it's just bangs that are also going to the left inlet here. Okay, I leave this troubleshooting stuff in these videos because I think it's valuable since you're trying to learn something to also see how to check things. So yes, the left here shouldn't be a 0. What else is going in here? Hold on. My frequency is hooked up to the wrong inlet. It should be hooked up to this one. The first inlet is the wave shape from the selector over here. Okay, save and close that. Okay, we're definitely hearing an envelope. Check the attack time here. It's releasing when I release the key. Let me make the release time longer though. There we go. It lengthened it just fine. Let's make our sustain level low, so I'm hearing some snaps and stuff as well as that sustain level sounds pretty similar to the peak level. I don't really hear much of a fall in it. Let me double check here. We'll be able to see numbers and math on the inside. Okay, so yeah, our attack time ends up being 40 milliseconds. Our decay time is ending up to be 8 milliseconds, that's all. Yeah, so that's not very long. Let's do this. Let's extend the decay time a bit more. I can make this shrink a bit so we can get back here to the subpatch. There we go. It's not calculating. Yeah, I altered the decay time. 0.83. Oh, look at this. Yeah, that goes through there like that. But yeah, look at the decay time. The duration's not hooked up to it. I gotta make sure it gets calculated, so that means sending one of the numbers through again. So let's do the decay time here. Alright. What? Still says 8. Here, I can move the number here. It's not changing. Got a trigger bang float going on here. The hell? Well, let's try something here. There, it changed. Well, this is negative values here. How did that happen? Put 0.3 in. Okay. Alright. I gotta check sustain here. This should be 34% of the amplitude level. I have an amplitude level of 0.144 here. And over here it's 0.45. Now it's louder. I don't hear really a fallback, even though the number's showing it should be. Okay, this number is going into the float here, and that gets banged after 10 milliseconds here. You know what I'm going to do? Instead of having that right inlet of the delay read that right away, I'm going to have it get this there. I mean, in other words, it doesn't go through the spigot. Because it gets stored in delay. It's not going to trigger anything, so it doesn't need to be stopped by spigot. So let's do this. Let's put in some new values here. Okay. There we go. Hold on. Okay, I'm going to adjust something here. I'm going to move all these packs down. The spigots I'm going to set up look at this spigot. Yeah, yeah. That isn't right. Yeah, these guys need to be on the other side. Now, these guys need to be on the other side of these. Okay. The decay time here. That always gets sent here. That doesn't get blocked by spigot. What gets blocked by spigot is this thing being sent. And in fact, this is for when the key's released after you know what? Let's hook this up again here. This is the attack time. It gets hooked up here. That's all fine and dandy. This is all fine and dandy. This spigot I have in here for when this gets hit. No. No, no. No, 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 no. No, hold on. That was fine. Okay. Yeah, this blocks this from happening. And if I put it in here, it'll block it from happening. Okay? In case you release the note before the decay time is triggered. Otherwise, the decay will always be pushing its way through. The attack does not need a spigot at all. Alrighty. The spigots were blocking information that needed to go through. So what I'm going to do is set my values again. I was over spigoting. Decay time, let's just make it long enough to hear it. Sustain level, keep it down there. And then release time, I can hear that it's working already. That's fine. That's not the problem. Now in sine tone, I'm not hearing a big amplitude change. Down to the sustain level. It should be getting triggered after this is hit. Although it only comes out if the spigot's open. And the spigot should be open right away to let it through after the attack. I'll have to check it on the outside on the audiometer. Perhaps it's just hard to tell with a sine tone. But the release seems to be working just fine. Like if I hit it short, let's extend the release time a little bit more. There you go. It's a really slow release there. Okay, so that's working. even if I play it short. And then when I sustain, that's good. Put the decay time somewhere around there. Okay, I'm going to test to see if that sustain is working from the outside here in the audiometer. Play higher pitch. No, it is not decaying down to a sustain level. Okay, so we still have one more item to fix. So the attack is coming through, right? We have the attack time here. This is a problem. The attack time should not be what's triggering that. The decay Alright, this is a trigger, float, bang, float. And I think it should just be a float, bang. Basically, this, the actual velocity that gets sent out as the first part of the pack message, that is what is supposed to go out the pack. First outlet, and that's what triggers this to happen. Because that's what triggers that the attack has come in, which triggers it to wait before banging the delay portion. The decay portion. This is the delay time as well as the message here. Now, there we go. I'm hearing it now. Yay! That's what you gotta do. You gotta trace things. That's why I leave these things in, so you can see how to trace. You see that? There's a fall in amplitude there. Here, I can make it more pronounced by making the sustain level a lot smaller. There you go. And now let's increase the decay time. Okay, now let's put the duration at 5,000. There, that was a longer decay time. Now we're at the sustain level. Now we release. There we go. Cool. Now, I may work with this a little bit more to refine some of the numbers to make it more and more convenient, but that's just going to happen over time. Basically, the system's working, and over time, you can test different values out and then find just the right range for things like what's going to be convenient for you. But its quickest is 1,000 duration. Let's see, if I put the attack all the way down, decay right about there, sustain level, keep it low so I can hear it happening. That's me playing some keys before releasing others when you hear it bubble like that. I'm just seeing what effect it gives. Basically, since we'll be making this do monophonic and polyphonic, I'm going to put a mechanism in that will make that better. But right now, we got our stuff working. And you just got to make sure which numbers are going where. Now let me do this. Let's just make this look a little nicer for now. I'm going to put, since everything is in increments of 150, height and width wise, I can fit things in pretty well. And make it look all nice and pretty. Almost. Alrighty, there we go. Now let me tell you where we're going next. We now have, I can even make the window smaller. There we go. Fit it all on screen. It looking nice. Here, Control A, select all, move it over a little bit. There we go. And so, this display isn't working because that's a sine wave, not a square wave. Alright, so let's fix that real quick. Why? Well, load bang. That's right. A bang isn't enough to turn on a toggle. You got to send it a 1. So, make a message that's a 1. And then our load bang should set it up right away. Now we may want to make a load bang for the ADSR as well that we just made. Here, let's turn this on. Okay. There we go. Now, the reason why it sounds a little muddled is when I'm hitting keys, and if I hit another one before releasing the one before, it does that. And that's because I didn't put in anything in the MIDI module to kind of make sure it goes to other notes in the right way for being monophonic. Well, that's because I'm going to be setting up a mechanism for monophonic or polyphonic so that we can handle both. And so that's going to come in time. So right now I know that that's a problem that will be solved later when I make this the way I ultimately want it to be. Oh, our graphs are different colors. Let's fix that. Let's change this to, I believe this is the color right here. All these different grays. All right, there we go. Now, switch. I might eventually change the table size and things so that, you know, your waveform always looks more visible. Because when you play higher notes, that looks almost like it could be a sine wave. Now let's try square. Oh dear. Dearie, dearie me. Let's fix that. So we go in here. I have a 0.5 going into pulse width on load bang. Because the main thing is to make sure it's not 0. But how come it didn't happen? Well, maybe I bumped that slider while playing with this thing and moved it down. But the whole thing is, as long as it's not 0, it should still work. And I have a lower limit of 0.01. Let's try it. Try this full range here. Yeah, it just sounds that way because of we can't go to 1 either. Well, that makes sense actually. So 0.99 and then make its size 99 because there's only 99 values there. And in order to keep these numbers from getting too long, that's good. That's fine and dandy, baby. Alright, now another thing I'm going to do, I know I was going to wrap up, but then I find all these things to do at the end. Well, this is stuff you got to do. You got to test it all out. I should have a load bang for this, putting in some values to begin with. That would be good. Just so that there is an envelope to start. So I'm going to put in a message for the attack time of maybe 0.1. I tested it at its extreme range, and it doesn't pop like it was before. After I fixed my patching, it got rid of that. So we're good there. Decay time. How about a 0.4? Okay. I'd like to keep this here, but no, I'll move these down here. How about a sustain level of 0.8? Not there. Here. Move you back over. And then a release time. Let's go with 0.4 again. Just reuse this one. So that'll be our defaults when the patch opens. It's good to have some values there when the patch opens. You don't want to be moving things around to get sound when a patch opens. You'd like it to work as soon as you start playing. Alright, the whole monophonic polyphonic thing is something that comes later, so yeah, that issue is understood right now. Okay, so anyway, we got this working as what it is for now. There's still work to be done, obviously, because we want to be able to put in some more processes, and learning different types of forms of modulation, for example, is definitely within the scope of this tutorial series. Filtering is another. But before we get there, what I'd like to do is hook up the pitch bend for control over here, because right now it's not hooked up, so it doesn't do anything. But it needs to control, it's more logical for the oscillator to come before the ADSR. Sorry. But that will be the next mission, will be to hook up the pitch bend and do the math for that. So you can see how that works. And I think what we'll also do by the next one, well, we'll see. I'm going to have to think about it in the meantime, but definitely we're going to put in the pitch bend, and then we're going to put in, at some point, the whole fixing of the MIDI thing. Because even though we're not going to necessarily make it polyphonic right away, although we kind of could, at this point we could start building polyphony in. So I think that might be a good idea. Although it's like two different subjects, so maybe I'll put them in two different videos. That's probably a good idea. But next time will be pitch bend. Definitely that is a little complex, and you got to get that mechanism in first before you do the polyphony and monophonic thing. And then we'll add the polyphony and monophonic thing right after that. There we go. I know my mission for the next two lessons. So anyway, there we go. Let me save it. I'm going to zoom out here. Please. Thank you very much. And I'll go back to the website. Incidentally, like on these videos, let me click the title here, get to the YouTube channel. Yeah, the default sound device is something else. That's why we're not hearing it. That's good. Don't want to interrupt the lesson. But anyway, what I want to do, here's the YouTube channel, is encourage you that after you hear these videos, or watch them, I assume you watch, what I really would like folks to do,
totally revolutionary with every single plugin that they're doing.
No one else kind of does what they do.
I would certainly reach for initially as being the first attempt at solving a problem.
I literally couldn't believe what I was hearing.
Try them.
Try them. Somebody's advertising something and at the same time. So well, anyway, lwmmusic.com. Here's the previous video on the learning. But basically, page. Okay, so the more comments put down the browser here. And I have PD set up here, and come up in searches. I have a folder here really just for this lesson that I will zip up. Please do drop in comments if you can. And the first and file then likewise, which is this blank if you have a question, you can leave it in the comment box, and I'll get back to you. I'm calling MIDI in via email. Because we're going to make a MIDI input module first. In an upcoming video, I'll put it in. So what I'm going to do, and give myself a little more space here. You can say in that comment. And then I should, if you don't want it to be used in the video, then I won't, So come join me in the Zoom. Not mine, in the whatever your alias is. Remove the magnifier out of the way. Yes, you get to be part of the whole show. So what we're going to do here is folks, that's it for this time. Oh, shoot. I was looking at the mouse on screen there and thought it was mine. Okay. That's enough for today. Take care. Okay, so I hope you enjoyed this tutorial on the ADSR envelope. And as is traditional, Crafty has some things he wants to say. He was kind of bugging me a little bit earlier. And so, Okay, well, Crafty says your fly's open. What? What do you mean by that? Oh.